Imagine you're a Viking sailor steering a wooden longship through storm-tossed seas 1,000 years ago. You have no compass, no GPS, no radio. Yet somehow you know exactly where you are, able to cross open oceans with uncanny accuracy. Now, imagine that the same technology, forgotten for centuries, echoes in the instruments we use today, even in the tools that guide astronauts across the void of space. This is the story of Viking technology that didn't just conquer the seas. It may have predicted the very methods of space travel. The challenge of Viking exploration. The Viking Age, beginning around the late 8th century, was an era of daring exploration. From the coasts of Norway and Denmark, their ships pushed outward, braving some of the most treacherous seas in the world. They sailed not just to raid, but to settle, to trade, and to discover. The Norsemen colonized Iceland, reached Greenland, and even established a short-lived settlement in Vinland, believed to be in modern-day Newfoundland, Canada. What makes these journeys extraordinary is the sheer scale. Sailing from Norway to Iceland is over 900 miles across open ocean. To Greenland, more than 1,200 miles. These aren't coastal trips. They are deep-sea crossings where land disappears for days on end. The natural question arises, how could Viking navigators accomplish this centuries before the magnetic compass arrived in Europe? Navigation by nature. We know the Vikings relied on a deep knowledge of their environment. They read the flight paths of seabirds, the smell of salt marshes carried by the wind, and even the color of the water, which hinted at depth and proximity to land. Whale migration, the drift of floating logs and the shapes of waves, all these were clues. But as ingenious as these methods were, they could not explain how a Viking ship could sail straight across the foggy North Atlantic. The missing key was something more advanced, something hidden in plain sight: the sun itself. The Sunstone legend. Icelandic sagas, written centuries after the Viking Age, mention a mysterious object, the sunstone. According to the tales, sailors used it to locate the sun's position when clouds covered the sky, or even when the sun had dipped just below the horizon. For years, historians assumed this was poetic embellishment, Norse myth rather than fact. But in the 20th century, researchers began to reconsider. A polarizing crystal, like Iceland spar, has the ability to filter light. Hold it to the sky, and the crystal splits light waves into two images. Rotate it until the brightness balances, and you can determine the exact direction of the sun. This means that the Vikings had access to an optical navigation tool more than 500 years before the compass changed European exploration forever. Experiments and modern science. In recent decades, experiments confirmed the practicality of the sunstone. Scientists tested crystals under overcast skies and twilight conditions, and the results were startling. Even when the sun was hidden, navigators could estimate its position to within a few degrees, accurate enough to maintain course over hundreds of miles. In 2013, an archaeological discovery made the case even stronger. A piece of Iceland spar was found on the wreck of a 16th century English warship near Alderney in the Channel Islands. It lay in close proximity to navigational instruments. This suggested that seafarers may have continued to use Viking-style crystals well into the age of sail, long after the compass was known. So what does all this have to do with space? Think of the problem NASA engineers faced in the 1960s. They needed to guide spacecraft across vast distances with no landmarks, no roads, and no possibility of correcting course with ordinary compasses. Instead, they turned to the same principle the Vikings relied upon: the heavens. Apollo missions used star trackers, optical devices that measured the position of stars relative to the spacecraft's orientation. Today, Satellites and probes still rely on celestial navigation systems, many of which analyze light patterns to calculate direction. Even more striking, modern researchers have experimented with polarization sensors to mimic insect eyes, tiny devices that detect the angle of sunlight through polarization. These sensors could one day help spacecraft or Mars rovers navigate when GPS signals are unavailable. What does that sound like? Exactly what the Vikings were doing centuries earlier with a crystal. Nature as technology. We often think of technology as machines, wires, and engines. But for the Vikings, technology meant something different, harnessing natural phenomena. The sunstone wasn't a manufactured device. It was a natural crystal, but used in a profoundly intelligent way. This parallels how scientists today build instruments, not by ignoring nature, but by imitating it. The Vikings remind us that technology is not always invention from scratch. Sometimes it is observation, understanding, and clever application. Archaeologists have reconstructed what they call the Viking sky compass. It combined a wooden dial with a sunstone crystal, allowing navigators to align their ship with the sun's position. Tests of replicas show that it worked astonishingly well, even when the sun was low on the horizon or hidden behind cloud cover. Now, compare this to the gyroscopes and star trackers used in modern spacecraft. The principle is the same. Fix your orientation using a celestial constant. Whether sailing to Greenland or Mars, the logic holds true. But the Viking relationship with the sky went deeper than crystals. Their mythology reveals a people who looked upward and outward. They spoke of Yggdrasil, the world tree that connected the realms of gods, giants, and humans. They described Bifrost, the shimmering rainbow bridge between worlds. Scholars suggest that these myths may reflect astronomical observations, the Milky Way, auroras, or the arc of the sun across the sky. To the Vikings, the cosmos was not empty space. It was a living map of meaning. Navigation was both practical and spiritual, a way to move through the world and to understand one's place within it. This worldview resonates with modern astronauts who describe the overview effect, a profound sense of unity and cosmic connection when seeing Earth from orbit. Lessons for today. Why should Viking navigation matter to us in the age of satellites and AI? Because it demonstrates that human ingenuity has always been about solving impossible problems with limited tools. The Vikings had no compasses, no sextants, no electronic sensors, but they had a crystal and the courage to trust it. Today, as we prepare to push into deeper space toward Mars and beyond, we face challenges just as daunting. Electronic systems can fail. GPS won't work in deep space. Once again, we may turn back to the simplest and most reliable guide, the light of the heavens. In this way, Viking technology doesn't just belong to the past. It may very well belong to our future. A broader view of human innovation. The story of the Sunstone is also a reminder that history often underestimates ancient knowledge. For centuries, scholars assumed that the Norse sagas exaggerated or fabricated the idea of a magical crystal. Only recently have we realized that these stories held scientific truth. How many other technologies lie hidden in myth, waiting to be rediscovered? How many ancient ideas could inspire modern innovation if we dared to look at them through new eyes? The Viking Sunstone is a bridge across time, from seafarers navigating foggy seas to astronauts navigating the stars. The next time you see a crystal sparkling in the light, imagine it in the hands of a Viking navigator. That shimmering stone wasn't just guiding them across oceans. In a way, it was pointing toward the stars. Because long before humanity reached space, the Vikings discovered a technology that predicted how we would get there. And perhaps, just as the Vikings looked across the sea and imagined new worlds beyond the horizon, so too do we look across the stars and imagine what lies beyond.